Okay, let's see what happened. Multivibrator. Multivibrator is a circuit that can between the two digital level, okay, on a continuous free running based on or demand from external trigger source. Basic, there are three types of multivibrator. Number one, by state, it triggers into one of the two digital states. That means just a flip-flop are stable if free running oscillator that alternate between two digital levels at a specific frequency and a duty cycle. Okay. Number three, monostable, also known as one source provide a single output pulse of a specific time length when is triggered from an external source. Okay, basically we get three different multivibrators that are bistable, that are flip-flop. Second thing are stable, and the last will be monostable. Now we're talking about capacitor charging and discharging rate. Delta VC, that means the voltage charging on the capacitor, equal E times 1 minus E power minus T over RC. Okay. Delta VC is change in capacitor voltage over a period of time T. E voltage difference between the initial voltage on the capacitor and the total voltage that is trying to reach. And E will be a natural logarithm equal 2.718. Okay. T is the time that the capacitor is allowed to charge. R resistance in ohm and C capacitance in farad. Okay. Now you see the circuitry here. Okay. You get the source at 5 volts and you get a switch. They can move to 1 or 2 or 3. In order to connect to resistor 10 kilo ohm and the capacitor 0.047 microfarad. Okay, and now they're giving you the example. First thing you have to remember, the formula to calculate the delta VC, that means the voltage charging on the capacitor, equal E times 1 minus small e power minus T over RC. And the T will be calculated by RC log of 1 over 1 minus delta V over E. Example 1. The capacitor in the figure number 1 and this circuitry here initially discharged. That means the capacitor will be 0 volt at beginning. Determine the voltage. Okay. On the capacitor, 0.5 milliseconds after the switch is moved from position 2 to 1. That means they want to moving from number 2 to 1. So the current will be go to the 10 kilo ohm charging in the capacitor. Okay. And they want to know that delta VC. That means this is the formula you have to apply. Okay. E. Then you have to know what E equals. And the E will be, you can see in here, what E? E, voltage difference between initial voltage on the capacitor and the total voltage that is trying to reach. Okay. So if you want to calculate the E, then you need to know the T. T will be 0.5 millisecond. Okay. And you substitute using those two formula. You can get the calculation. If you get the right one, the answer will be 3.27 volts. Okay. And the second one, the capacitor in figure number 1, initially discharged. They're telling you at the beginning, the voltage on the capacitor will be 0. How long after switch it moved from position 2 to position 1 will take for capacitor to reach 3 volts. That means from this formula here, T equals R times C. You already know R and C. Log 1 over 1. Only thing you need to get a delta V and E. Okay? If you're doing the right one, you can get T will be 0.431 millisecond. And the next one, the capacitor in figure 1 initially charged to 1 volt. How long after the switch is moved from 2 to 1 will take for the capacitor to reach 3 volts? And the answer will be 0.326 milliseconds. That means you have to using T equal RC log 1 over 1 minus delta V divided by E. Okay. Can you tell me what delta V equals? Number 3. If you read it, you can see initially they charge to 1 volt. That means at the beginning they already 1. And they want to move until capacitor charge to 3 volt. So delta VC will be 3 minus 1. Okay? And the other thing you have to know what E. E will be the difference between the initial voltage on the capacitor and the voltage on the capacitor try to reach. And we know initial voltage on the capacitor will be 1 volt. What the voltage on the capacitor try to reach? Who can answer for me on that? That means you're moving from number 2 to number 1. Okay? And they will be keep charging on the capacitor. If you know how to calculate the delta V and also E, then you can get the answer will be 0.326 milliseconds. Delta V, you already know at the beginning, they do 1 volt, and they try to reach, they will be take to reach 3 volt. That means delta V will be 3 minus 1. However, the problem is E. Who can tell me what E is supposed to be? Okay, look like you guys still not quite understand. E here, what E equal? E means the difference between the initial voltage of the capacitor and the voltage capacitor try to reach. Initial voltage, they say 1 volt. What the voltage capacitor try to reach when you move from number 2 to number 1? What the voltage capacitor try to reach?
Oops.
Who knows? When you move from 2 to 1, if you take long time or forever, what the voltage try to reach? They have to be 5 volt, maximum charge. So E will be equal 5 minus 1 will be equal 4. Okay? And you can apply to the formula to calculate it. Try to see you can get right answer. Okay, same one. Okay? Then you can try to do it. Whatever. They say initial charge to 4.2. How long after switch move from position 2 to position 3? That means they connect already 2 to 3. Now they move to 3. That means to the right. For the capacitor to drop 1.5. So the formula using only T equal here, RC log 1 over 1 minus delta V divided E. So delta V, they say capacitor charge 4.2 volt ready. Okay. Now they go to number 3, they will be discharged. Okay. So they will take capacitor to drop to 1.5. They initially 4.2 and they want to go down 1.5. That means delta V will be 4.2 minus 1.5. And the next one will calculate the E. E again will be difference between initial voltage on the capacitor and the voltage capacitor try to reach. Okay. Can you tell me what is supposed to be? When they move from number 2 to number 3, the voltage they try to reach, that means they will be fully discharged. That means 0. Okay. Initially 4.2, they did that to be 0. So E will be 4.2 minus 0. Okay. And now another unstable multivibrator. That means this is the circuitry here. They're using the IC74 HC14. Okay. That's what they call a free running oscillator. That means they get a signal coming out, they keep running forever. Can build from a single Smith figure 74 HC14. When the IC power is first turned on, VC 0. That means when you connect the circuitry, you turn it on. At the beginning, output here will be short to the ground. That's a 0. So V out will be equal 5 volts. You know this is just an inverting. Okay, if you get a 0, you get a 1. Or you get a 1, you get a 0. Okay. Capacitor will jack up to 5 volts at the out. That means at the beginning you turn on the 0 and now you get a 5 volt here. Current will be going this way, charging on the capacitor. Okay. When they charging up the capacitor up to the point, logic at the input now will be 1. Then output will be 0. Okay. When VC reach the positive going threshold, VT plus of the circuit, the V out changing to a low, and V out equal 0. You know what that means for VT plus. For the logic TTL, you know the logic 1 will be 2 volt up to 5.5 volts. And logic 0 will be less than 0.8 volts. However, for this IC, they say that will be VT plus. That means they given to you what VT plus equal for this IC. Okay. And also VT minus. That means that logic 1 VT plus, VT minus will be logic 0. Okay. Okay, now you can see. Example, this is circuitry. Okay. They given you this signal. And this is a lower, okay, TP. It's a higher. Okay. Sketch and label waveform for the Smith RC oscillator, given the following specification for 74SC 14 high-speed CMOS Smith inverter. VCC equal 5 volt. V out high 5 volt. V out low 0 volt. VT plus 2.75 and VT minus 1.67. Okay. So at the beginning, at the beginning, capacitor just connect to the ground. V in is 0. Okay. And the V out will be 5 volt. Okay. And the capacitor will be keep charging. Okay. When they charge into the UTP, that means they charge up to 2.75. They're telling you, if you get 2.75 here, that means the logic 1 output will be logic 0. So that's why you see that they go to 0. When they go to 0, okay, and capacitor will be discharged, okay. When they discharge, up to the point will be 1.67. Logic low. Then the output will be high again. And it keep going, same thing. That's why you can get the signal output just like the square wave, logic 0 and logic 1 going. That's how they work it. They want to say what? Calculate the time high, T high, time low, T low, duty cycle, and the frequency if R equal 10K. That means if you get a 10K here, and the capacitor 0.022, microfarad. Okay, the answer will be T high, 86.2 microsecond, T low, duty cycle, and the frequency. Okay. T high, that means you calculate the voltage going capacitor from here to here. Okay. And T low, that means the voltage from here. T high and T low. Okay. Let's see. Okay, another one. True IC, popular. 74-121, 74-123. Okay. That means this very simple. The circuitry using IC 74-121 or 74-123 for the trigger. Okay, so basically you apply trigger here. When they going high, then the output Q will be going high. For how long? Depend on R external and C external. Okay. Then how long they can go in high, then they go low. And the next one, you get the same thing. Okay. And the same thing here, you can get the trigger here. Okay. When they go 0 to 1, you get the output going high. However, you get another one going, but this not changing. Okay. Depending on the TW. That means basically I and C. What they say, this force are ignored by the one source. Okay. One source, that means you click it one, they just going up. One only. Even you can going up again here, they not changing until the next one. Okay. Just a 1 minute. Okay, I don't know. Let's see. One student asking me, do we have a final lab by January 27 to complete the job? I have a complete on previous digital lab. I am stressed about if I can finish before the end of the semester. Okay, that look like just about very few students left over after the COVID-19. Okay, they get only up to the lab 14 at the final. So I'm going to go over to see on the lab in the past, they already done. Okay, that means the lab instructor have to tell me if you already done, then okay, that will be a favor for just a very few students left over. Okay. Next 2 weeks, I will let you guys know. If you get any question regarding into the program, just bring it up the question. Okay. The thing that we run quite different from city college. If you get into the same program, that means technician, electronic technician. Okay. In the city college, that take you 2 years. And basically, most will be more theory. So that's why you can get the homework, you can get the quiz, you can get the final test. Okay. But the thing is they not concentrate on the practical job the technician have to working at the company. That are quite different from the way for this technician program. This program only take you 1 year. Most of things try to take you, try how can you do your job technician in the company. That are quite different. Okay. So basically, if you're doing a good technician job in the in the program, and we can verify that, then you'll be okay. No big deal. Okay, so basically, this is just a very simple type of the circuitry. That means you're using the IC121 or IC123, and you're able to build the circuitry when you apply the pulse, okay, into the trigger here. They can give you the output look like, okay. But the thing is, we are not designer, so we don't care. Only thing is when you measure the output, you know you can get this kind of the signal. Okay, and now that is a little more thing. They call a 555 hammer. Okay, add one shot. So first thing they given you this IC. Okay, this IC only how many pins? 8 pins. Pin number 8, VCC. Pin 6, pin 5, pin 2, pin 7, pin 1, pin 4, pin 3. Pin 3 is the output. This will be internal of the 555 timer. Okay? And now I try to help you to understand what's going on inside that one. Okay? Now, example. If I get VCC equal 15 volt, what voltage here? Who can telling me what that voltage? Nobody know? Hey, man. So I have to study. Otherwise, you'll still be in Tech 2 forever. You can see you get 5K, 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 and this is the route. So the voltage in here will be the voltage divider. That means 5 times 10K divided by 15K. That's a voltage divider. Okay, so 15 times 10 and divide 50. What do you think you get? Fifteen times 10 divide 15. They're telling you you get 10 volt here. Okay, so what the voltage at this point? Who telling me? You know how to calculate the voltage divider. That means 15 volt time from this point to the ground. Okay, time 5 divide 15. So you get 5 volts. So that's the only thing you can see. You get depending on the power supply here. You know what the voltage here and what the voltage at this point. Okay? And now, next thing. This is what the name of the circuit. This one. If you're looking on that one, what is it? That's what we call a comparator. This is the op-amp. If they connect this way, they comparator, they compare input positive to the input negative. If the input is positive higher than input negative, output logic 1. If a negative input higher than positive, output will be logic 0. And that will be applied the same thing for the second comparator. They compare input at the positive with the input at the negative. If input at positive higher than negative, then output logic 1. If an input negative higher than input positive, output will be logic 0. Okay? That is how that comparator works. The next one. This one is what is it here? Who can tell me? Okay, we start at the next semester spring on up due. Currently in the tech two right now. Have to start over the same with the student from Tech 1 go to Tech 2. The thing is from that point, you will be get the free to get the homework and the test. If you cannot get through it, you can drop it out. Okay? The thing is you can stay forever in the program and cannot be complacent. Thing is when I did a very basic thing, I asking you, but the guy not answer me. You guys look like you guys don't know anything. That's what we cannot give in the completion certificate. Okay. Next thing. What is it here? You understand when you start learning the flip-flop, you're learning this circuit. RS, set and reset flip-flop. Okay. And the output Q. Okay. So depend on input S and input R. Q will be 0, or Q will be logic 1, or Q will be no change. Okay. And this is just an inverting. If you get a logic 0 here, then you get logic 1 at the output. If you get a logic input 1, you get a 0. If you get a 0, you get a 1 inverter. And finally, you can get that one. This is NPN transistor. Okay. An NPN transistor, they can be get on or they will be off. Okay. Suppose it's transistor Q1 on. What happened? If you're looking into the circuitry, if I say Q1 on, then what happened here? Okay. If Q1 on, they connect pin 7, whatever connect you, will go to capacitor and connect to the ground. Okay? So if you get to connect a capacitor in here, that means when the Q1 on, they will be discharged. Signal go here, go to ground. And if Q1 off, that means they not connect pin 7 to the ground. So basically Q1 just either they can be turned on or they will be turned off. Okay, my question is, how come we turn Q1 on? How come Q1 will be on? And you understand output Q here, depending on R and S, they can be at a logic 0 or they can be at a logic 1 at here. So when Q equal logic 1, that will be turned on, Q1. And if Q equals 0, they will be turned off Q1. So that I try to make sure when you're looking into the 555 timer IC inside, try to understand everything. Comparator, how they working, the flip-flop here, how they working, and the digital inverter. Okay, and also the transistor, NPN transistor, when they will be turned on. What happens if they turn it off? And when they will turn it off? And what happens if Q1 off? Okay, and you can see you get a one line in here. They don't call it reset. That means they want to reset this flip-flop. Okay, they connect to the ground, so the output have to be 0. Okay, any question up to that point? Okay. Now let's see. The 555 timer at a one shot. Okay. The pulse width of the output is determined by the time constant of R1 and C1. That means the output coming out one shot. That means they just go only one, zero, logic one, just one. And that TW, that means how width, can be calculated by 1.1 times R1 and C1. You see C1 here and R1 here. So basically, if we connect this circuitry, when you measure the output, you can see you can get a 1 point in here. Okay? And if you trigger keep going, then they will be keep running. That one here, that's how circuitry working. Okay, another one. The 555 timer at a one shot, the point weight of the output is determined by the time constant I1, C1, same thing. Only the difference here will be they can connect R1. Okay. That only thing is whatever out here. That means you have to make the connection in the dark here. That's the internal of the 555 timer. Okay. So they want the trigger here. That means they going from high to low. Okay. And whatever happens, that will be doing in the lab. Then you can see what the output look like. And also, they will be telling you, okay, when you get 0 to 1, and you get a 0 to 1 going up, and this one will be high, go to low. And inverter here, they will be low, go to the high. Okay? And this is the lab you will be have to do. Okay? That's a manual lab. That means like exactly the same in the left volt. However, we have to build, okay, in order to do it. And also, there's a little more detail. 555 timer at art stable multivibrator. You understand you get the first one. We telling you get a one shot. That means every time they get a trigger, then they go 0 to 1. At this, they going down. Just a 1. That's what they call a one shot. And now they go a art stable. That means now they will be go this way. Output they going up and they keep going. They keep going. That's a difference between one shot and art stable. Okay? And also they given you the frequency of our oscillator, okay, given F 0.144 divided R1 plus R2 times R2 and times C1. That means if you get the value of R1, R2, and C1, you're able to get the frequency on this trigger here. Okay? And the period of the signal, T will be T high plus T low. T high will be 0.7 times R1 plus R2 times C1. T low will be 0.7 times R2 C1. And this also calculate the duty cycle. T equal T high divided Ti plus T low times 100%. That is the one of the lab you will be working on. Okay? You have to rebuild the circuitry and calculate what the frequency is equal, what the period equal, what the high and the low. Also, a duty cycle. Okay, and another one, operation of 555 timer is stable. You see that? That means on that one, they given you a little more detail. Okay. This is telling you the voltage capacitor charge and discharge. Okay. And that will be connected to the circuitry here. Okay. And the output coming out look like that one. Okay. And this is simplified block diagram of 555 timer with the external timing component to form stable multivibrator. We already telling you, we get, let's see, at the beginning. Okay, we get bistable, stable, or monostable. Okay, bistable, they just working like a flip-flop. Stable, that means you get like free running oscillator. That means the output keep going. Okay, high, low, high, low, high, low. Monostable, also known as a one shot, that means they're using 555 timer. Okay. Okay, in here, they just given to you. Okay. For the voltage capacitor charging, then they did charging and discharging. Okay. And the output will be high, low, high, and low. Also, this is the formula. TW, okay, RC log 1 over 1 delta VC divided E. That's what we're talking about before, capacitor charging and discharging. Okay, and T low, this is the formula, but basically they equal 0.693 times RB times C capacitor and time high, and this is the formula. Okay, and finally duty cycle, D equal T high divide T high plus T low. And if you want to calculate the period from here to here, take T high plus T low. And if you want to calculate the frequency, F will be 1 over T. Okay? I hope next meeting, I will be giving you the problem. Okay? And we can work it out before we can do the lab. Okay, any question, anything? Okay, any question to me? Otherwise, we will stop it, okay? We'll see you guys on the next meeting. Make sure you want up whatever, you have to be in the meeting on the tech tube. Otherwise, I don't care. I cannot counting you anything for completion the program. Okay? So good night.
Good night, sir.
Good night.
Good night.